building quadratic functions. We're going to take what you already know from Unit 1 and we are going to build upon it. So they are going to describe in words what's happening to a parent function, f(x) equals x squared, and we're going to use this description of this translated quadratic function to create a new function. Alright, here we go. So this is the parent function. It says it's going to be vertically compressed by a factor of 2/3. So I'm going to write g of x equals, so 2/3 is out front. Why is it compressed? Because it's between 0 to 1. It says this function is translated 4 units to the right. Remember, inside describes the horizontal change. 4 units to the right, it's going to be opposite. So instead of going to the right 4 and going plus 4, it's going to be minus 4. And always remember, this has to have a square. Parent functions, we're working with degree 2 quadratic functions. And then it's going to be shifted down 5. Number 2, parent function. Again, everyone we work with right now is degree 2. Vertically compressed by a factor of 6/7. Again, this number is between 0 to 1. Translated 1 unit to the left. So instead of going minus 1, it's opposite on the inside. It lies to you on the inside. It tells you the truth on the outside. Translated, oh, it doesn't say going up or down, so I could put a plus 0 here. But when it doesn't get shifted up or down, you're welcome just to leave this blank. Go down to number 3. A parent function is vertically stretched by a factor of 5. This number is greater than 1. This number is greater than 1, which means that it will be stretched. It's going to open up downwards, which means it's reflected across the x-axis. Put a negative sign here. It's translated to the left 2 units. So we want to naturally think minus 2. We're going to do the opposite on the inside, and down 7. The parent function is vertically stretched by a factor of 7. Translate 3 down. So this time we're not going to move to the left or right. If you want to put plus or minus 0, that's fine. But it does need to be an x squared. If you don't see a number inside, it means it's not going left or right. But it is being shifted down 3. Number 5, it's vertically compressed by a factor of 3/4. Opens up downwards, which means it's reflected across the x-axis, denoted with a negative sign in front. Translate 11 units to the right. Opposite on the inside, and 3 up. Tells the truth on the outside. Okay. Parent function is vertically stretched by a factor of 3. It opens up downward, so there's a negative sign in front. Bless you. Is translated to the right 4 units, so opposite on the inside, and 8 up. Number 7. Same concept, compressed by a factor of 1/5. Opens up upward, translated 2 units to the right, so x minus 2 quantity squared, and then 4 units up. Number 8. Okay, it opens up downward. Now it doesn't say that it's compressed or stretched. That means that this number out front is a 1. It's not necessary you put a 1. It is necessary you put a negative sign, showing that it does reflect across the x-axis. Okay, it's translated 4 units to the right. I'm going to do the opposite. It doesn't say anything about a vertical shift. Number 9. Stretched by a factor of 3. Opens upward. Is translated 2 units down. Okay, nothing to the left or right, and 2 units down. And our final one is going to be compressed by a factor of 2/3. It opens downwards, so I'm going to put a negative sign in front. It's translated up 3, a plus 3, with nothing inside the parentheses because it's not being switched, not moved to the left or right.